Hello students, my name is Santosh Kumar and I am the course instructor for Machining Sciences and Tool Design. We are discussing module number 3, that is cutting tool materials and machining induced surface integrity. So in this video we will be discussing about primary cutting edge finish. So before discussing about primary cutting edge finish, let us understand what is primary cutting edge. As you can see, there is a major cutting edge that is also called as a side cutting edge, and then end cutting edge that is also called as a minor cutting edge. So we are discussing the primary cutting edge, that is the major cutting edge, which is inducing a surface integrity once the workpiece is cut using this cutting edge. And corresponding angles also you can observe, as there is a side cutting edge angle, end cutting edge angle, and there is a clearance angle. For example, there is a side clearance angle and then end clearance angle and also back rake angle, which is shown. So we will be referring to this clearance angle and the back rake angle in the further slides. As you can see in this slide, so the knowledge of the finish produced by primary cutting edge is not only of direct importance in where the resultant surface is generated by major cutting edge, but is also of importance in interpreting the wear on the clearance faces. So that is what I am telling. It is not only important to study the resultant surface, but it also helps us in interpreting how the wear happens on the clearance face of the cutting tool, which is having a nose radius, because this will be our subject of interest, because we are more interested on the tool wear. As you can see in the figure, the left hand side figure indicate the type of finish may be conveniently studied at a low speed using a planing arrangement, or you can have a high cutting speeds by by cutting the end of the tube under orthogonal conditions using a doubly O-ranking tool and an axial feed. So when the work material is not available in the form of tube, that is as it is not available in the left side, so you can go for the right one, which is having an analog tool, which is convenient to use. So in the analog tool arrangement, the feed and depth of cut are interchanged. So as you can see in the figure, so alpha x and alpha b is in this direction. So whereas here it is interchanged. Okay, so that is your feed and depth of cut is interchanged, and also back rake angle and side rake angles, which we discussed in the previous slide, are also interchanged. So by doing this in the second case, that is in the analog cutting process, you can see the helical uh, tool path is generated, so which is having a sufficient head width, so that we can measure it through the tracer. So the comparison of the surface finish profiles are shown in this slide. So as you can see, in the left hand side, the finish produced, it's morely dependent on the cutting speed and the depth of cut. So the finish are for low speeds. For example, in the left hand side you have 30 meter per minute, 60 meter per minute, 90 meter per minute, 120 and 240. As you are increasing the cutting speed, so the surface finish is improving. Well, as you decrease the cutting speed, the surface finish produced by primary cutting edge decreases. Similarly, when I trace this with in an axial direction, so that is this left hand side is in circumferential direction, and in axial direction, when it is traced, as you can see here also, as the cutting speed is decreased, so the surface roughness is decreasing. So that is, you are getting a very rough surface, as discussed in the previous case. So this was about primary cutting edge finish. So we will end this video here.